I've said it before, I'm a child of the 1980s, and every boy that I know that was alive between the ages of 8 and 14 and saw Michael Keaton's Batman in 1989, the coolest thing we had ever seen was that scene where the Batmobile has the armadillo-style armor that populates across the Batmobile to protect it. Just blew our minds. It was so cool. And of course, you know, years later, like The Matrix came out when I was in college, I think, and there were so many cool things in The Matrix that were just so alien, you know, from bullet time to you know, the way that they kind of blurred their motions as they were, you know, blocking punches and all of that. It was just mind-bendingly cool, right? And superhero movies. Everybody loves superhero movies. Why? Because superheroes, it's all fantasy, right? But they move and they can do things in ways that we don't expect because we live in a reality where physics kind of is stifling almost. It's like a prison of physics. Like, you know, we can only jump 40 inches high if we're really good at jumping or something, you know, like, you know, typically it's constrained, right? We can't do that much awesomeness in reality. So how cool is it that we have Delta printers? These things defy expectation. Just watching them print, I've stared at this thing for hours. I've stared at all of my Delta printers printing for hours, and it's still cool to me. I still love watching them. They're science fiction embodied in reality. They obey the laws of physics, and yet somehow, because of the triangular motion, because this goes up and down and it keeps the platen, or I guess you call it the end effector, it keeps it flat. It doesn't twist. It's perfectly flat. It's just so strange and so cool. And not only that, these are the fastest printers that you can make because there's the least amount of inertial mass. So the end effector plus the rods plus the trolleys weighs less than almost any other kind of printer that you can make. But of course, there's a trade-off to that lightweight and just cool looking motion. And that's the fact that they are not as accurate as Cartesian, you know, X, Y, and Z style printers. So that means that they don't make perfectly square or perfectly round parts. So if you are making engineered parts, that's not your best bet. Although I do prototype all the time with my Delta printers because I can get a printout in like sometimes like the quarter of the speed that it takes me to print on one of my more accurate printers. So for very fast prints that I don't need perfect accuracy on, I mean, the accuracy is decent. So yeah, they absolutely have their place. I absolutely love them. And that printer that I just showed you is probably my most refined Delta printer. So I'm going to walk you guys through all of the upgrades that I've done to it pretty quick, just to give you an overview. And then I'm going to give you a kind of a highlights look into the firmware that I made to get it all working. Let's get into it. The fundamental flaw with Delta printers has everything to do with the way that they move, with the way the movement is calculated. As you can see, these arms travel on an arcing movement, and that means that things are variable. 1 unit of movement here does not equate to 1 unit of movement at the carriage. So if we have a 45-degree axis, right? So let's draw a dashed line there. So that's our 45 degrees, and we want to move 1 unit down in the X, or I should say in the Z direction with this trolley here. Let's just do this symmetrically about the 45-degree axis. So we'll start half a unit above the 45-degree axis up here, and we'll end half a unit below the 45-degree axis there. So this 1 unit will equate to 1 unit of movement there. So on the triangle, 1 unit equals 1 unit. This means that in the middle, when the rods are all angled at 45 degrees, just like that, the movement is 1-to-1. So the closer you are to the center, the closer we are to being the same accuracy as a regular Cartesian printer. Now let's look at an opposite example, an extreme case. If we're out here like this and we want to move 1 unit in the Z direction here. So this is 1 unit, and our rod again is 10 units long. That means that this side here is 9.95 units long. So for 1 unit of movement down here, we're going to only move, because this is going to move to be where the rod is completely horizontal. So we will only move 0.05 units in the X direction there for 1 unit of movement there, which means there's a 20-to-1 ratio at the far extents as we're approaching horizontal. So any defect, in other words, any slight inaccuracy, the belts maybe are just slightly, production of the belts is done in such a way that they're not completely, the teeth aren't completely meshing perfectly with the motor driving them, or whatever it is. Your stepper motors aren't calibrated perfectly. Any of the most tiny imperfections is multiplied 20-to-1. Let's look at it this way. If we turn this triangle up on its side, right? So again, we're on a 20-to-1 ratio. Then if I move down by 0.05 units, so let's just say we're dealing with millimeters here. 0.05 millimeters is half the thickness of a piece of paper. So 0.05 times 20 equals 1 millimeter. So if I'm out of calibration by the width of a half of a piece of paper, then I'm going to be moving 1 millimeter incorrectly out here at the edges, at the far extents of the travel. Down here where my rods are approaching horizontal. Not only that, but your speed has to increase and decrease. So here at 45 degrees, if you want to move a certain, millimeters per second in the horizontal plane, then these trolleys have to move that same horizontal. But again, down here at the extents, to get that certain speed down there, this thing has to be moving 20 times more quickly than the horizontal speed you want from the end effector. So the bottom line is you really want to print as close as you can to the center of the bed. The wider you go, the more problems you're going to have with the machine having to print rapidly, and the more inaccuracy you're going to experience in your finished part geometry. But there's another problem with the accuracy of Delta printers, and that is in the rod lengths. These things all need to be exactly, and I mean exactly, the same length. And if they're out even just a little bit, then the end effector here does not stay horizontal. As it travels through its movement, it's going to do this kind of a thing. A little bit of, call it eccentricity. It's going to have a bit of wobble to it. So why does that matter? Well, it matters a lot when it comes to bed probing. You can see here I've got this BL Touch probe sitting off to the side of my nozzle. My nozzle is here and the BL Touch probe is there. So as we're at some point in the travel, if I'm off like this, my BL Touch is measuring high. And if I'm off like this, my BL Touch probe is measuring low. That's why it's really hard to get an accurate first layer laid down with a probe that sits off to the side of your nozzle. What you want is to have a probe directly under your nozzle, or you want the nozzle itself to be the probe. And that's why, even though it's less convenient, the fact that this printer here has a detachable probe that sits directly underneath the nozzle, this technique is actually superior to the BL Touch on this printer. Every time I use it though, I have to plug it in and remember to unplug it. So I kept forgetting to do that. And you can see the damage, sort of the carnage on this inner part of the probe where I had my nozzle up to temperature and I started trying to print, or, because I forgot to take this off after probing the bed. And so I wanted a way to make this idiot proof. And in order to do that, I put this button on the printer. And this thing here activates a macro inside in the firmware. I'll show you guys that in a few minutes. So when I press that, it's going to start heating the bed, because you want the bed to be up to print temperature when you're probing it. So it's going to get the bed up to temperature, and once the bed is at temperature, it's going to do a calibration routine. And there you have it. Now, what if you're printing, you're in the middle of a print, and you accidentally press that button? If I press it again, nothing happens. In the macro, I was able to deactivate the functionality for this button after it runs one time. So now we can pop off this sensor, and it gets stored right back in the slot, and we get a double layer of protection. So the way that it's stored, it's blocking access to that button. You can't accidentally press that and accidentally activate the algorithm. The final piece here is I didn't want these wires dangling and hitting the print or whatever, so I made this little clip up here to hold the end of that. I forgot to mention that this whole geometry slides into the square cutout that was originally intended for the USB plug. Now, as far as retaining the sensor in the cutout there, the sensor itself has a magnet which it kind of finds its way home and sticks to the side of the printer. So of course, there's a Duet Wi-Fi in this printer. I'd made a whole video about installing this into the FLSun Q5. By the way, FLSun Q5, this is the one to get. There's a QQS printer that FLSun also makes, and I would stay away from that because the 2020 rails and these pulleys, or these plastic Delrin V-groove wheels, this is a pretty rigid motion system, but the QQS is a larger printer and it relies on 8mm rods, which are flexible. So you can see there's a lot of horizontal force, back to this discussion. We also have, like a 20-to-1 force ratio going through this. So if you're way down at the ends of your movement, you're moving 20 times, 20 times the horizontal speed here, and you're trying to start and stop it instantly, basically, which is going to cause those rods to flex. You need a real stiff motion system. So I would steer clear of the QQS. I know a lot of you guys have bought it, but that's why I haven't reviewed it. So yeah, I made that whole video about installing the Duet board into the Q5 here, and you guys can go watch it, link in the description. But then I did a follow-up video not that long ago about installing this emergency stop button here. And this one obviously interfaces with the Duet control board, and it's not actually a stop button, it's more of a pause button. So if I see a problem happening with my print down here, I can just hit that and it'll raise, and the head will lift up off the print. I can get in there and maybe clip away some dangly filament or whatever's going on, hopefully fix the issue, and then just go like so, and it'll unpause itself. So I hear you asking, why did you have to install a button? You can just do that right here on the web interface. See, there's the pause button, and that'll be, red when the print is actually printing. Well, sometimes I don't have this right next to the printer. Sometimes I'm sitting over there on my computer and I hear a noise and it's going to take a minute to open up the web page or whatever, and I want to just run right over here and hit that. Of course, if I had the $80 Duet screen that you can buy, there would be a big pause button on it, but this is a $3 button, and that's about the only functionality that I need to activate sitting here at the printer. And now we can get a look at what I've done to the Hotend/end effector. You see this nice part cooling duct? I'm really quite proud of that. This screw here mounts in a slot, so you can actually adjust this part cooling so that you get it to be just the right height off the nozzle. None of my other designs have that ability. It's kind of difficult to get to function, but in this case, I was able to make it happen. Over here we see the boss. This has the plate that the magnet for the sensor mounts to. So I had to design that to get it to be just the right length to get around the E3D Volcano Hotend. So that's the hot block from an E3D Volcano. And that gets you much higher flow, which is nice to have when you're printing at very high print speeds. I typically run this thing at 100 millimeters per second. You can see I've installed a Noctua silent fan, and it's clipped on to the heat sink of the Hotend, just with like this hood, just kind of wraps around the side of the heat sink. So this is just sort of, I could pop it off if I really wanted to. So all of this geometry is available to my $5 Patreon supporters. That's the way I always do it. I'm not trying to sell 3D printer geometry, but it's just a nice reward for those of you helping me to keep the channel going. So let's start a print and I'll show you guys the pause function. You guys ever have the problem where you start a print with some dribbly filament hanging off the nozzle? Then when the print starts, you notice it and you can't quite get to it because it's printing. Problem solved. So all of these additions are cool, but I'm betting a lot of you are wondering when I'm going to upgrade these joints to being zero lash magnetic ball in socket joints. And the answer is never. So you can see I've got this rubber band here, and there's many types of sort of spring assemblies that hold these rods together just to try to relieve some of the motion out of the system. So there's a little bit of play, a tiny bit of play in these joints. If I get real close, you hear that kind of click, 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 click. That's the lash. That's the play in that system. Over here we see steel balls in magnetic sockets, and so that makes for zero lash. There's absolutely no play because the magnets are always, magnetically surface touching, so you don't have any wiggle in there. The problem is what I just showed you guys. These things can pop out of joint, and that tends to happen when you're printing at higher speeds and making a rapid change of direction. So let's say you're making a rapid change of direction at a corner where the corner is peeling up ever so slightly because you didn't have enough part cooling. And this really does happen, especially with these small part cooling fans. See, like that one right there? That makes almost enough cooling. We're right at the limits of it for these, the E3D Volcano Hotends, but it would be much better if we had more part cooling. So probably a bigger fan would help alleviate the sort of peeling you get at the corners. But even without that, there's still a possibility that just that change of direction could be enough of a jerk to pop it out of joint. And this happens to me. Probably 1 in 5 prints printing at top speed on this printer pops out of joint. And whenever it does, that's a ruined print. So I don't think the added benefit of zero lash magnetic joints is worth the risk of ruining your prints 1 in 5 times. Or, hey, this DIY solution that I made here uses weaker magnets. There's sort of more professional kits out there that probably have double the strength of the magnetic holding force, holding those balls into the sockets. But yeah, I don't know. I think I like the captive solution better. I do. I trust it more. You can't go wrong. Before we talk about the firmware, let me show you guys where we're going to be wiring everything in. So here we can see this bottom right pin. That is a ground pin, and the next pin over, that is that's the E2 stop signal pin. So E2 means it's actually the third end stop because we start with 0, E0, E1, and E2. So we're going to use those 2 pins, that ground, the farthest pin closest to this corner here, and the next pin over, we're going to use that one too. Those are the 2. And it doesn't matter which wire goes to which, but those are the wires that we're going to connect to our emergency stop button here. And this is an interesting switch. It's got 2 conditions. It's either, this is like open and then it's closed, and then you click that, it's back to open. So it's kind of a toggle switch. And if you look at the back of it, there's 3 markings. The bottom pin here in this case is marked with a C, and that stands for common. And then the next pin up is marked with an NO, that stands for normally open. And what that means is if you have like a light bulb and you don't connect the light bulb, you don't connect the wires to the light bulb, that's open. And then when you connect the wires, now the circuit is closed and the light bulb will turn on. So normally open switches open like this, and when you press the button, it turns the light bulb on. But you have the other type of switch which is normally closed, and when you press the button, it opens. So it turns the light bulb off. And this switch will do both, and we could get either way to work very easily in firmware. But the way that I have it set up is to use the common and the normally open, so the bottom and the middle pin. For the other momentary switch, the one that goes with the bed probe that controls the frame adjustment algorithm, as well as the G29 bed mapping algorithm, we're going to use the E1 pin, and that's the one that's right above my finger there. So this one, I'm covering it up right now. And we're going to use the outer 2 pins. So it goes signal, power, ground, and we don't need power. We just need signal and ground. And it doesn't matter. You can flip those. It doesn't matter which one goes to which. And if anybody's confused by that, you can find this pinout diagram easily on the Duet website. Just search Duet 2 Wi-Fi pinout, P-I-N-O-U-T, and this will pop up. The ground pin you can see there, and then the next pin over is the E2 stop. So that's easy enough. And then right there, that final 3-pin connector, that's our E1 stop. Here in my web browser, we see the web interface into the FLSun Q5 printer with the Duet board, and we can do everything else to the firmware that we need to right here through the web page. So starting off with, let's start off with config.g. So this is the main configuration file that goes along with your firmware. And down here at the bottom, we can see I've got 3 M581 commands going on. And the first 2 have these comments. Anything after a semicolon is not code, it's English meant for the human to read. And yeah, so those explain that. It's a rising edge, trailing edge thing. So it's not looking for the switch to be closed or open. It's actually looking for the change from open to closed. The second that changes, that's what's actually triggering the switch. So pretty cool stuff there. And for this is the M581 command for the bed, tramming, all of that. Yeah, so pretty easy stuff. You guys can look at that code. And of course, this is available to my Patreon supporters along with all of the STL printable geometry for all these other upgrades. So, but yeah, you can, I don't know, you guys can see that, right? Hopefully you can pause it and figure that out if I'm not making it clear. But the final thing we need to know here is this T5 for the frame calibrating. When you press the other momentary switch, it activates this T5, which is trigger number 5. You can see that right here in the comment. So if I close out of here and scroll down to the bottom, we can click on trigger 5. And I could have made this any one of them. I could have made it trigger 1, trigger anything, I think 0 through 9, maybe it's 1 through 9, but no more than 9 triggers that you can have. But still, I mean, I only need the 1. I just chose 5 arbitrarily. Anyway, this is the series of G-code commands that are going to run when I press that button. First, it's going to wait until it gets the bed up to 60 degrees. Then it's going to run 2 G32 commands. This is like a rinse, lather, and repeat. You get better results by doing it twice in a row. And the G32 is the Delta specific G32 command, calibrates the frame. So it adjusts for inaccuracies in the frame. And then after that, it's going to run the bed mapping, mesh bed leveling algorithm. That's the G29. And then the final thing is this M581, which looks just like the command that activated this trigger 5 in the first place. But the key to this, to giving this command kind of within the command, is the S-1. So that inverse turns the command off. So now if I press the button again, the command, this whole trigger 5 is invalidated until I reset the control board or turn the machine off or whatever, off and on. So it's a good idea for you guys to take this command right here and copy it and paste it into your start G-code of your slicer. So as soon as the job is started, you can't accidentally trigger all of this, frame calibrating, bed mapping stuff, which would, of course, ruin the print if it happened mid-print. And I need to give a shout out to my Patreon supporter, Alex. This is the geometry that he came up with. He took my upgrades and went one step further. And yeah, you can see that is basically the same idea as what I've implemented. So that's where I came up with that one. It wasn't my creation there. And you can see he's done some other stuff here in the under the hood. He's added this circuit board and he's got a bigger fan. And yeah, so he's changed it up a little bit. Because there's really no reason that you guys can't take my upgrades, all of my printable STL files, and add to them or change them a little bit and make the printer yours. But, I really have gone to the effort to make these, all the machines that I upgrade, and this one in particular, I've tried to make them the most functional printer for the least amount of money. And I do think I succeeded here. I'm going to call this one the FLSun Q5 Evolution. And if you don't have the skills or you're not really confident and really wanting to customize it, I think you'd be best served to just follow my upgrades. It's going to be pretty easy to accomplish, and you're going to end up with a great machine. Speaking of which, I think this is where I'm going to leave this machine. It's perfectly functional for me. There's nothing, there's no major issues I want to address with it. I would love to get the accuracy better, but that's not really doable. Not realistically. I would need to make some custom jigs or some crazy thing just to get that frame perfect and to get all of the rod lengths absolutely perfect. Just the mechanics of it, just to increase that accuracy. So I do have a couple of other videos for you guys to follow if you're going to do this build. Most importantly, this one here, and also link in the description, to the installation video for the Duet 2 Wi-Fi. And I'm running RepRap Firmware 2.05, even though RepRap Firmware 3.2 is out, I think. But you know, the RepRap Firmware 3 was primarily made for the new Duet control boards. It's trying to be backwards compatible to the Duet 2 control boards, but it's of minimal utility, and it's a bit more difficult to get installed. So I've just stuck with the old firmware. And you can get the firmware as well as the configuration file from me if you are one of my Patreon supporters. So I don't think I'm going to do anything more to this printer. I think that it's in its final form. That being said, I will, I think, have an extra, $250 Slice Engineering Hotend that's not on a printer. So there's a possibility, just because I have it, I might install it onto this printer. And I do love that Hotend, but it's going to be better, but only a little bit. And probably, that $250 price tag is a lot for most people to swallow. And so that marginal gaining utility probably isn't worth it. Best to just stick with the E3D Volcano upgrade, which is quite fantastic. Works quite well on this machine. All right, I'm gonna leave it there. A big thank you to my Patreon supporters. That's these guys, and without them, I've said it before, I would not be making videos. This is the reason that I keep doing this. So that being said, I have to give a sincere apology to, there's a few of you guys who've been very friendly, reaching out to me with long personal messages, and I would love to respond and be all of your guys' buds. But I don't have the time. I can't even get all the videos. I have like a laundry list of videos, like 20 videos long that I can't even get completed, let alone spending time with my family and all that. I'm just one guy. So as much as I would love to be friends with all of you guys, I will, however, respond as quickly as I can to all of the sort of requests for files and quick, troubleshooting. So if I can help you guys get that done. So yeah. Anyway, thanks for watching. See you next time.